Hi students, today we are going to discuss chapter 7, that is cube and cube roots. So here you are seeing on the screen the portrait of two great mathematicians, Professor G.H. Hardy and the Indian mathematician Mr. Srinivas Ramanujan. So let's talk about the story of 1729. Here it is 1729. So once G.H. Hardy visited the Mr. Ramanuj in a hospital using a taxi cab numbered as 1729. Okay, so there was a conversation between the two mathematicians uh, regarding this particular car number, that is 1729, and G.H. Hardy said, I am I am getting nothing about it. How dumb is this number? But this Srinivas Ramanujan, as the name, he was a great mathematician. He instantly replied that it is the interesting number. It is the smallest number that can be expressed as the sum of two cubes in two different ways. That is 1729 can be expressed as 1 cube plus 12 cube, and also it can be expressed as 9 cube and plus 10 cube. So it was a quite interesting number in the vision of Mr. Ramanujan. So why we are studying this? Let's understand cube. You know about the word cube. Cube is used in geometry. A cube is a solid figure which has all its sides equal. Here you can see it is a cube and all its sides is supposed to be equal. Now here you can see there's a figure, one more figure for the cube, and there are three things, that is the edge, face and the vertex. If you count the vertex, that is the corner point, we would have 4 on the top and 4 on the bottom, so it has total of 8 vertex. Sorry, it has total of 8 vertex. Now counting this edges, it has total of 12 edges. Okay, and if you count the faces, that is the number of walls, so it would have 6 faces at all. Okay, so the examples of cubes are like this Rubik cube and the dice. Okay, now let's talk about the cube numbers. What are they? Consider the number 1, 8, 27, 64, 125. Okay, so these numbers are called the perfect cube or the cube numbers. Why? Because each of them is obtained when a number is multiplied by taking it 3 times. For example, if you say 1, 1 can be expressed as 1 into 1 into 1. Okay, similarly 8 can be obtained as 2 cross 2 cross 2. Okay, similarly 27 can be expressed as 3 cross 3 cross 3. So a number is multiplied thrice in order to get a number. That number is called the cube number. Okay, let's talk about the number of cubes from 1 to 10. Okay, so in the previous chapter we have discussed the square, or for a to obtain the square of a number we have to multiply the number twice. Okay, we have to multiply the number by itself, but in order to get a cube we have to multiply it thrice. Okay, so for 1 its cube is 1. Okay, for 2 its cube is 2 into 2 into 2, that is 8. For 3 it is 27. For 4 it is 64. Now it can be expressed as you have learned in the previous chapter, that say square can be written, that is for example 25, it can be written as 20 as 5 cube, but sorry 5 square. Okay, but if we talk about 27, it can be expressed as 3 cube. See here, the 27 is written as 3 into 3 into 3, so it can be expressed as 3 to the power 3 or 3 cube. Similarly, it is 5. 5 cube is 125. For 6 cube it is 216, and so on. What can you say about the ones digit of the cube of a number? We have discussed the ones digit of a square of a number. Let's talk about the cube. Here, 1 cube, we write it as 1 into 1 into 1, and we got 1. Okay. Now, for the larger number, we say it's 3. So 3 cube, 3 3 is a 9, and 9 3 is a 27. So we can say that is the 3 cube ends with digit 7. Okay. Similarly, 4 cube is 64, and 64 ends with 4, so 4 cube ends with digit 4. Similarly, 5 ends with 5, 6 ends with 6, but the 7 ends with 3, right? For example, 7 into 7 into 7, so we know 7 sevens are 49, and multiplied by 7, so we got as 343. So we can say that is the 7 cube. Okay, and this 7 cube ends with 3. Okay, similarly 8 cubes ends with 2, and 9 cube ends with 9, like 9 into 9 into 9, this is the 9 cube, and 9 nines are 81, and multiplied by this 9, so 9 ones are 9, 9 eights are 72, so 729, it is the 9 cube, and it is ending with the 9. Okay, and here 10 cube ends with the digit 0. Now, can you find the ones digit of cube of each of the following numbers? For example, it is 1. So we know 1, if you multiply this number, so this number is ending with this 1. If you multiply this thrice, you got 1. So we will say the whole number, that is this whole number, when you cube this number, it will ends with 1. Similarly, here it is 8, and 8 ends with 2, so the cube of this number ends with 2. And it is 9, so if you multiply this number thrice to obtain the cube of given number 149, it will end with the digit 9. Okay, now adding two consecutive add numbers. In the previous chapter we have discussed that a perfect number can be a perfect square number can be expressed as a sum of consecutive odd natural numbers. Okay, the same is true for the cubes. We can obtain the cubes of a number using a particular pattern. Here you can see that is 1 cube is 1. Okay, and 1 is the first odd natural number. The next two odd natural numbers are 3 and 5, and if you sum these, we got 8, and 8 is 2 cube. Similarly, next three next three odd natural numbers are 7, 9, and 11, and it sums to 27, which is a 3 cube. So next four odd natural number, okay, these are 13, 15, 17, and 19. Okay, so these sums to 64, and it is a 4 cube. Okay, similarly we can find the next five odd natural number, which will sums to 125, and it is a cube of 5. Okay, now there is it not interesting how many consecutive odd natural number will be needed to find a sum of 10 cube? Okay, now see here, if we adding two numbers, we are getting 2 cubes. If we are adding 3 numbers, we are getting 3 cubes. If we are adding 4 number, we are getting 4 cubes. Similarly, if we are adding 10 numbers, we will get 10 cube. So we need 10 consecutive odd number in order to obtain the sum of 10 cube. Okay, so let's solve the try these. Express the following numbers as the sum of odd number using the above patterns. So we have to find the 6 cube. Here we have seen the 5 cube, so we will find the next odd natural number, next 6 odd natural number, that is from 29. So number would be 31 plus 2, 33. Okay, then adding 2, we got 35. Why we are adding 2? Because the odd natural numbers are separated by a digit of 2. Okay, it is 39 and it is 41. Okay, so it would be 31. This is 1 2 3 4 5 and 6. We have got 6, and it will be equals to the 6 cube. Okay, so similarly you can solve for the 7, and then you will solve it for 8. Okay, so now we have a pattern over here. Consider the following pattern, that is 2 cube minus 1 is equals to 1 plus 2 into 1 into 3. Okay, similarly 3 cube minus 2 cube is equals to this. Now using this above pattern, we have to find the value of this. Okay, so let's understand the pattern first. Okay, we say this second pattern, that is 3 cube minus 2 cube. Okay, so if you see all the patterns over here, these are there is something in common, that is first is 1, so I will write 1 for each, then I will write plus. Okay, so now you can see here it is 2 1, it is 3 2 3 2, it's 4 3, it's 4 3, right? So if you are seeing this number 7 cube minus 6 cube, so we will write this pattern as 1 plus the number is 7, we will write 7 multiplied by next number, that is 6, and here 3 is common, so I will write this as such. Okay, so if we solve this, we got 1 plus 42 into 3. Okay, and it would be 3 2 just 6 and 3 4 just 12 plus 1, so the answer would be 127. Okay, similarly you can solve this. Let me elaborate it for you. This pattern will be like 1 plus 12 into 11 into 3. Okay, similarly this pattern would be 1 plus 20 into 19 into the common number, that is 3. Okay, and you have to solve it by yourself, and all this here you have to solve these numbers using BODMAS strategy. Now cubes and their prime factors. What are prime numbers? Prime numbers are those numbers which has only exactly two factors, what is 1 and other is the number itself. Okay, so here the prime factorization of a number and its cube, for example here it's 4, and prime factorization of 4 are 2 cross 2, but the prime factorization of 64 are 2 to the power 6. There is 6 times 2 written here. Okay, so it is written as 2 to the power 3 and multiplied by 2 to the power 3. Okay, similarly 6 is 6 having the prime factor as 2 cross 3, but its cube 216 has a prime factorization of 2 cross 2 cross 2 and 3 cross 3 cross 3, that is 2 cube cross 3 cross 3 cube. Okay, similarly for 15 it having the prime factorization as 3 cube into 5 cube, and for 12 it is 2 cube 2 cube and 3 cube. Now why we have written this is as 2 cube? Okay, so it is the key point here. Let's talk about a number that is 729. So how would we know that it is a perfect cube or not? Okay, let's prime factorize the number, and if you prime factorize the number, we got this 3 6 times 3, that is a group of 3 and another group of 3 containing 3 element in each. Okay, 3 element in each, and the 3 similar elements should be there. Okay, so this 3 cross 3 cross 3 and 3 cross 3 cross 3, we have two groups. Okay, so we are getting a group of 3 element, and that is needed for a number to be a perfect cube. So yes, 729 would be perfect cube. Let's talk about another number. Okay, here 500. If you prime factorize the number, it will be 2 cross 2 and cross 5 cross 5 cross 5. Here 5 is a group of 3, but 2 isn't in a group of 3. Okay, so if it is not in a group of 3, so it is not a perfect cube. Okay, for a number to be a perfect cube, there should be another 2, so that there will be a group of 2. Okay, having 3 2's. Okay, let us talk about some world problem. Okay, so we will face two kinds of problem here. The first type is find the smallest natural number by which a given number must be multiplied so as the product is a perfect cube. Okay, we are given here a number, that is 392. We have to check whether the number is a perfect cube or not. Okay, if it is not a perfect cube, then which number is there by which if we multiply it there, so that the product will become a perfect cube. Okay, so first we will figure out the prime factorization of the given number. So the prime factorization are 2 cross 2 cross 2 and 7 cross 7. Here 2 is in a group of 3, it is okay, but 7 is not in a group of 3. We needed one more 7. Since there is a uh, insufficient 7, so it is not a perfect cube. So now we will multiply it by 7. Okay, but the equality says we have to multiply the 7 on the right. So the number would now 2744. Okay, and we will get a pair of a group of 7, a group of 3 7, and a group of 2. A group of 2 and 7 are there, and both are fulfilling the conditions of 2 cube and 7 cube. Okay, so it is a, now it's become a perfect cube. Now let's talk about find the smallest natural number by which a given number must be divided. Okay, so that the quotient is a perfect cube. Okay, the first question, for example, here 1184 88, is it a perfect cube? So let's figure out its prime factorization. So the prime factorization are here. Now here 3 is in a group of 3, so it's okay, but the 2 and the 11 are not in a group of 3, so we want to divide, so we will eliminate the unpaired group. Okay, so we will remove this 2. So if we want to remove this, we will divide by 2 cross 2. Okay, again we want to eliminate 11, we will again divide by 11. Okay, so now we will completely divide it by, or we can say we are dividing it by 44. Okay, 2 2s are 4 and 11 4s are 44. Okay, on dividing by 44 on both sides, we got 27, and here we will get only a group of 3 because all the ungroups are eliminated, so we will get a group of 3, that is 3 cube. So 27 is 3 cube. Okay, so we will divide it by 44. So 44 is that least natural number by which we have to divide, and the question is now a perfect cube. Here it is an assignment for you. You have to solve these assignment in your